Okay, so Assalamualaikum. Today we're going to continue our synchronous class, the third synchronous class, which is for the combustion process, which is we're going to look for the what is it? Apa nama tu? The combustion with moisture, and then reverse combustions. Okay, so moisture content and then the reverse combustions. So I hope that we can finish today. Okay, so let's see. But this both of the problem that we're going to look today will be look on the theoretical combustions. Okay, which is the it only involved with the stoichiometric combustions. Okay, so let's see that if we have combustion with the moist air, liquid, the similar fuel that we're going to use, which is the liquid octane CH06 at 25 degrees Celsius, at 1 atmosphere, injected at 310 Kelvin, and then the entry temperature 310 at the rate of 120 degrees Celsius and exit at 1000 Kelvin. The mass flow rate of fuel if the relative humidity of the air enters at 60% of the relative humidity, and then you have to calculate the rate of heat transfer for the Q dot. Okay, so initially that we have done the chemical balance for the problem, which is C8H18 plus A theoretical O2 plus 3.76 N2 X CO2 plus Y H2O plus Z N2. So this is the theoretical combustion, whereby yang masuk lambat tu I will after this slide baru saya masukkan. Kalau tak nanti dia kacau the slide. Alright, so with this our cuba baca sikit dia punya result yang ini, berapa chemical balance kita for this one, C8 H18 berapa? Cuba tengok from the previous. Apa kita punya tu?
X equal to 8.
Okay. C8 H18 plus 12.5 O2 plus 3.76 N2 8 CO2 plus Y apa? Y18, Y9 Y9 H2O plus Z sama berapa? 47. Berapa tu? Berapa nilai Z? 42. 47 and 2. Okay, so now the temperature the air enters at 310 Kelvin. Okay, so which means that 310 is equal to what? Berapa banyak? And then the relative humidity is 60%. Okay, and then 310 tolak dengan 278. Ya, tolak dengan 275 sama dengan 98 tolak 25. Okay, 273 sorry. Tambah 310 minus 273, 37 degrees Celsius. Okay. Oops. 37 degrees Celsius, which is you kena interpolate lah dekat sini kan. Kalau interpolate tu dapat berapa? 35, 40. So this is going to be 0.4, 7.38 4 bahagi tolak dengan 7.384 tolak 5.628 times 0.4 plus 5.628 6.33. So PG at 37 degrees Celsius equal to 6.3304. Okay, kilopascal. Okay, so the chemical balance for the this one will be for the combustion with the moist air effect is CH18 plus ATH, sorry, plus this one is the 12.5 O2 plus 3.76 N2 plus NH2O H2O P equal to 6.3304 kilopascal, Y which is equal to P H2O over P air, sorry, P atmosphere, and then equal to N H2O over this is for the Y for the H2O, and then N atmospheric air for the atmosphere, and then Y for air is equal to P air over P atmosphere and air divided by N atmosphere. Okay, so the information that we know, relative humidity is equal to P H2O or PV over H2O over PG at temperature at 37 degrees Celsius. So PV2 or PH2O is equal to 0.6 times 6.3304 kPa, which is equal to 0.6 times 6.3304, 3.798 okay, kilopascal. Now we need to find the number of mole for total. Okay. From this equation, O is equal to number of mole P H2O over P atmosphere times with the N atmosphere or mixture, okay, which is give you 3.798 over 101.325 kPa. This is also kPa. Right, so number of mole is berapa tadi ya? Kita punya value 12.5, 12.5. 4.76, yeah, 4.76 times 12.5. Okay, number of mole for the air is equal to 4.76. Sorry, yeah, number of mole for the dry air plus number of mole for H2O, which is number of mole for the dry air is equal to 12.5, and then O2 plus dengan N2, which is 1 plus 3.76 kilomole, okay, plus NH2O, okay, which is 59.5 plus NH2O. So kalau you masukkan di equation balik, NH slownya 2O equal to 3.798 bagi 101.325 darab dengan 59.5, 2.23 plus 2.23 NH2O. Okay, so berapa tu nilai NH2O? Is equal to 0.23 salah ni. Oh, betul. 2.23 ya, sini salah. Berapa tu? 3.798 bahagi 101.325. 2.2 0.0 0374. Okay, NH2O, which is 0.0374. 1 minus this one, 2.23 bagi answer. Okay, 2.317 kilomole. Okay, so our chemical balance will become, ingat ni 2.317. Okay, 2.317. CH18 plus 12.5 O2 plus 3.76 and 2 plus berapa tadi? 2.317 H2O produce 8 CO2 plus 11.317 H2O plus 47 and 2. Yeah. Okay. So from here you can calculate the air to fuel ratio AF, which is masih lagi maintain ya. AF mass flow rate of air lagi mass flow rate of fuel, which is we give you sama juga 15 point sebab dia ambil untuk dry air saja ya, which is we give you about berapa tadi, 15.12 something like that, 15.12, and then your mass flow rate untuk fuel is equal to 120 bahagi dengan 15.12, 7.936 gram per second untuk fuel. Then the the enthalpy of equal to summation of product, enthalpy for the product tolak dengan enthalpy for the reactant. So for the reactant, first kita tengok C8H18 which is dia sama dengan apa? C8 C8H18 equal to 1 enthalpy of formation for the C8H18 minus 249 minus 249 520 and obtain 950 plus 0 minus 0. Okay, so you dapat minus 249 950 kilojoule Kelvin, yeah. And then for nitrogen, H N2 sama dengan 1247 Enthalpy of formation dia sama dengan kosong plus 310 ya, 310 9014. Tolak dengan 298 8669. Sembilan kosong satu empat tolak 8669 kali dengan 47. 16215 kilojoule kilomol. Okay. And then oxygen H2O2 12.5 enthalpy formation 0 plus oxygen 9030 minus 8682. Okay, which is equal to 9030 minus 8682 kali dengan 12.5 4350. Tolong tulis nanti ya. Okey. Tolong tulis nanti nilai dia, ideal. Tulis value dia semua ni minus 249. Tulis nanti ya. So how much enthalpy for the reactant?
Negatif 249,950.
Negatif 249,950 tambah 16 215 lagi tambah 4350. Lepas tu tambah dengan H2O lah kan. H2O tadi berapa? Minus
H2O tadi
minus.
Minus.
Yang ini tadi tak nampak ada dia punya ni kan. Saya ingatkan tadi tu H2O. Okay, so enthalpy untuk CO2 equal to 8. Kira balik semula tadi. Salah tadi yang tadi ya. 8 kali dengan carbon dioxide 393 minus 393 520 plus yang ini 47 42 769 minus 9364. Berapa tu?
Negatif 2840.
Negatif 2840 lagi 920 kilojoule kilomol ya. Alright. Kilojoule kilomol. Tolong ingat nombor tu ya. Okey, yang ni H2O, ni baru betul H2O. Tadi saya salah ambil tadi nombor ni kan. Saya tak ambil H2O tadi kan. Betul lah saya tak ambil H2O tadi. Okay, so this is H untuk H2O equal to berapa? 11 11.317. Minus H2O vapor minus 241 820 minus 241 820 plus 35882 minus 9904. Okey, ni baru betul. Berapa tu? Berapa tu?
Negatif 2443.
Negatif 24.
2443.
Okey.
362.9.
362.9 kilojoule kilomol. Okey, tambah semua. So, enthalpy of formation, enthalpy the reactant, enthalpy of the product. Allahu Akbar, kenapa teruk sangat ni? Enthalpy for the product sama dengan berapa tu?
Negatif 5284.
Lagi?
282.9.
282.9 kilojoule per kilomol ya. So, negatif 3486. So, enthalpy for combustion ya, negatif 3486 903.16 ya, kilojoule per kilomol. Okay, so nilai Q, nilai so that's dalam bentuk itulah. So H equal to negatif 3486 903.16 kilojoule per kilomol bahagi dengan mass number dia berapa? 114 114 kilogram per kilomol. Sama dengan berapa tu? Berapa nilai dia? 3486 903.16.
Negatif 305.86.
So 586.87 kilojoule per kilogram. Okay. Tak ada kilomol lah. So and then Q dot is equal to H kali dengan M dot fuel, which is minus 30586.87 kilojoule per kilogram darab dengan 120 tadi 937 gram gram per second, which mean that darab dengan bagi dengan 1000 and then kilogram per second. Okay, dapatlah jawapan dia.
Negatif 242.77.
Negatif 242.77 kilojoule, kilowatt lah. Kilowatt kilojoule per second ataupun kilowatt. Which is previous numbers was minus 25 something, 252 atau 259. Yeah. So as you can see here, with the moisture content existing in the combustion chamber, it will reduce the amount of the heat released from the combustion process. So sekarang ni apa? 10 dah. Okay. Alright, so saya rasa tak sempat kot untuk yang nak ke satu lagi je. Satu problem satu jam lebih. Aduh. Macam mana nak buat reverse process ni? Kita ada, we going to have another 3, which is reverse process, reverse combustion process. Okay. And then yang kedua, combustion for gas. And then yang ketiga, combustion for solid fuel. Okay. So untuk next class saya akan bagi macam mana, but I try to make Google apa ni dululah kot. Try to make YouTube punya kelas dulu, ya. Kalau saya tak sempat untuk discussion, kita buat yang YouTube punya kelas. Okay. Alright. So sekarang pun dah pukul 10. So I think I will end up the class sekarang because saya nak kena masuk another meeting pula. Okay.